How will you feel on exam day? I, Byron Lagrone, walked into my first Cisco exam confident I knew it all. Yep, definitions, no problem. Routing protocols, old hat. And of course, wait, what? Subnetting? Who cares about that? Well, as it turned out, the Cisco exam board cared about that. A lot. And they still do. At the end of our discussion today, you will understand everything you need to know about calculating subnetworks. This knowledge will ease your nerves on exam day and assist you in passing on the first try. I will first explain the concept of a subnet mask. Then, I will define in detail how to calculate all of the components in a subnet: network address, broadcast address, and usable host addresses. At the end, I'll walk you through one comprehensive final example. At first glance, a subnet mask looks a lot like a really weird IP address. There are still 4 octets of bits, each separated by a period. But for a subnet mask, network bits are represented by 1s are like a basket holding the subnet together, and host bits are addresses within the subnet, stuff in the basket, if you will. And subnet masks must be consecutive, so all 1s, when it switches over to all 0s, can't ever change back. You see, we have a problem in the third one there. When we pull up an ipconfig, or whatever command we're using on a host device, the subnet mask appears in decimal form, as shown. If we write this out in binary format, it's 3 octets of 1s and 1 octet of 0s. So whenever we see that subnet mask, we'd count up the 1s and see 24 network bits and 8 host bits. We humans can also write out a subnet mask in slash notation, like there with the /24. That's just the number of network bits, and it's much easier to write or say than 255.255.255.0. Now that we know how the mask is put together, let's examine the reserved addresses in a subnet. The network address is always the first address in a subnet, and it just denotes what network we're working in at the time. The broadcast address is always the last address in a subnet, and it's used to broadcast a packet to all of the hosts in a particular subnet. Neither of these are usable by host devices. So let's say that we saw this IP address with a /23 mask. We'd know immediately that /23 means that we've got 23 network bits, so we must therefore have those followed by 9 host bits. And since those are going to tick over in the third octet basically every 2, so 0, 1, and then 2, 3, we know that our network is going to start for this one at 172.16.4.0 and end at 5.255 with our broadcast address. The host addresses, that is to say the usable addresses, in a subnet comprise all remaining addresses in a subnet not already taken by the network or broadcast addresses. These are the valid IPs that a machine could pick up from DHCP or static assignment or otherwise use. So suppose we're given this network address, 172.16.44.16, with a /28 subnet mask. There are 4 hosts available, decimal 16, meaning we enter a new subnet every 16 addresses. So with that network address of .16, we know that our usable host must be .17 through .30, and our broadcast address clocking in at the last address in the subnet, .31. Cisco loves to make you count by 16s, so it may be handy to start memorizing now. You could try counting sheep to go to sleep. Just make sure there's 16 sheep, and that counting by 16s is easy enough for you to put you to sleep. Okay, so it's a little hard. But it's not time for sleep just yet. I'd like to walk you through one more comprehensive example before we depart. So, suppose we're on a PC and we see it has this IP and subnet. Let's take a closer look at that subnet and convert it to binary. Now that's going to be 26 network addresses there, and then, 26 network bits and 6 host bits there at the end, giving us 64 addresses in that subnet. So if we fall down from 80.82 to the nearest 64, we get that our network address must be at 44.64, and we notate a /26 if we'd like. And our broadcast is going to be the last address available before we tick over again to another 64 at .127. So our usable range is the 62 addresses located from .65 all the way through .126. If you're not thoroughly sick of subnetting by this point, you may be a good candidate for a Cisco certification. You can check out this book for further reading and more subnet practice. Remember, the concepts we have learned today will help you pass your Cisco exam on the first try, provided you continue to practice them every day.